So when do we actually do some programming? Right now, or basically when we get into the lab. We're going to go through the exercises. There's 3 exercises, and they are going to teach you a lot about programming, because you're going to use everything we just talked about and a bit more that you'll pick up along the way. So exercise 0, because we start counting from 0, is a series of relatively straightforward programming tasks. With all of these things, people get caught out because they assume that I'm trying to be tricky. These were basically the easiest things I could think of to write. And so exercise 0 shouldn't be overly tricky. That's the whole point. If you think, oh, this is too complicated, you're thinking about it in a too complicated way, not taking it the way I intended it, basically. So exercise 0 has a series of these little tasks. And so here we've got one called add 1. So this one's actually filled out in the way that it needs to be done. So add a number. So if we look at these things, there's a few bits and pieces that we need to have a look at. So we've got the def, and then we've got the function name, and then we've got the argument, right? So we can use that argument inside our function. If you don't use the argument, it will go kind of grayed out. And that's a good sign that you're doing something a bit wrong, because the argument is there for a reason. If you don't use it, then the test won't pass. Then below that, you've got this triple quoted string. And triple quoted strings in Python are used to define what you're supposed to do. They're called doc strings, and they document what a function does. So in this case, it's telling you what you need to do. And so what we're doing here is we're saying variable, the answer is, we're assigning to that variable a number, which we're getting from the arguments, and then we're adding 1 to it. So +1, that's the maths that I was talking about in the last video. So we add 1, and then we return the answer. It's important that you return a value, because if you don't return anything, the function just throws it all away. Okay. This is my VS Code, and I'm going to do a little bit of live coding, I guess. So you get to see me actually running through my thought process of solving these problems. I'm going to leave in any bits where I make mistakes so you can see how I fix them. And so what we're going to do is read the doc string for the whole thing. This is the doc string for the whole exercise. So let's have a read of it. Modify each function until the tests pass. The command to run the tests is python./course set2 test.py. Same as last week, but with 2 instead of 1. Then in each function where you see the answer equals none, we've got to replace none with the actual answer. Okay, seems simple enough. So this is the first function, add 1. So we have the word def, which says we're defining a function, then the word add 1, which is the name of the function, and then an argument, which is a number. We're going to pass that a number and see what it does. So how can we return a number that is 1 bigger? So the question here is return a number that is 1 bigger than the number given. So pointing out this isn't a trick. I'm not trying to trick you. This is kind of super simple, so it should be pretty straightforward. So this is an example which shows how everything works. So the answer equals a number +1, and then we return the answer. So that's the structure for all of these future exercises. That's one ready, done. You've already got that one. So we can move on. We can see that that works. So we're going to do a number add 5. So we want to return a number that is 5 bigger than the number given. So we can see that our number is grayed out. See how a number here is nice and bright and this one is grayed out? It's because it hasn't been used yet. So what we want to do here is say, okay, the answer is currently none. So the answer is not none because the answer wants to be something something. So if we look at the previous one, we can say the answer is a number +1, but to add 5 we want to say and as I type, a lot of things come up and it's helpful. So I can see that that says our number. I can either click that or press tab and it will finish it off for me. That's super useful because it stops you from making spelling mistakes. And it also makes you a lot faster. And so faster and easier is always good in my bet. So plus 5. And then up here we can see this white dot that says that this hasn't been saved. So we'll save it. Okay. Now, let's work through how this is going to work. So we've got a few ways of doing this. We can either do the most basic run, which is just this button over here on the right, run file in terminal. So we can scroll up a little bit and we can say add 5 to 1 gives 6. That's cool. Or we can do it with the debugger. So we can say run the debugger, and that does more or less the same thing. Just takes a little bit longer. So we can see here, same, add 5. And so this test is tested 4 times. This exercise is tested 4 times. So we add 1 to 5 and it gets 6. We add 6 to 5 and we get 11. We add -3 to 5 and we get 2. We add 0.5 to 5, we get 5.5. So those things are all expected. So let's do that in a slightly more complicated way, and we can put in a breakpoint. We're going to talk about this in the little next section, but I'm just going to skip ahead and do it now. So we'll tick that, which is in the gutter. I'm going to talk about gutter in a second. So this is the gutter, and now we can run the debugger. And let's close that just so we have a bit more space. So now we've got the way we call this is execution is paused on this line. And so currently we can see the state of our environment over here. So all we have at the moment locally, which means inside this function, is a number, and a number is 1. So 1, this resolves to 1. 1 plus 5 is 6. And so this button here steps over the next line. So if we step over, then we get a new variable created over here called the answer, which is 6. And then we return, which means give that value back to whoever called that function. And that gives us back 6. That takes us down to there. We can skip over this. You don't need to know that much. That's just calling the function. It's annoying. Right, so when we get to these mini tests. Now the mini tests, you don't need to understand really how they work. They're just there to make your debugging a little bit easier. But what it's doing is calling the function with the number 6 and expecting 11. So let's try that again. It'll call it again. So now, inside add 5, our number is 6. And so what we want to do is guess what's going to happen next. So we expect the answer to be created, and we expect it to be 11. And when we do, it is. Okay, so that's great, it works. So we can stop debugging, we know that that's fine, we can move on to the next one. In this case, we want to make a slightly more complicated function where we want to add these two numbers together. So I'm going to copy that and paste it there and replace that comma with a plus. And so the answer is a number plus another number. This is pretty simple, right? Now, this one, we're going to get into some string manipulation. And this one takes a little bit of reading to do. So the thing you're going to have to do is take this and go to the docs and look for the function that converts a string in any case to a string in uppercase. And I'm not going to go through that one. I'm going to let you do it because it's good exercise in actually reading the documentation. The rest of these kind of do more or less the same thing. So it's all modifying strings, doing things with numbers. The only thing that I will point out here is that in previous years we've sort of pushed you towards using something like this. Now that's fine, but recently in the sort of professional work I've been doing, I've been going through and making a real effort to change that over from that format, which is convert the number into a string and then concatenate it, which means to join together, concatenate, into this string. So we get a thing that comes out at the end. What I have been doing a lot more recently, which I think is a lot more readable and it's also a lot more robust, is something along those lines. So let's like that. So this is called a format string, and a format string is just a lot more readable and a lot more robust than using concatenation. So if you can avoid using a concatenation by using a format string, you should do so, because I think it's just a much more elegant way of writing your code. All right, so that's it really for exercise 0. Exercise 1 is a fully functional file. It works perfectly well. So the whole point of this file is to get you into the idea of debugging. So debugging is a process of stepping through a file to understand how it works. And that links nicely in with the philosophical ideas that I was talking about last week. The idea that it's a constant process of refining your relationship to reality. So if the program doesn't do what you want it to do, you have to understand why it's not doing what you want it to do, and then you can change it. And if it is doing what you want it to do, but you don't know why, you have to change the way that you think about the world so that you understand it a bit better. And we do that through this process of stepping through the code piece by piece. So you need to use this button on the left here, the little triangle with the play button, or little triangle with the bug, sorry. And that will give you the debug window. And you click the little green play button up here, and that will start the debugger. But if you just run that without having set a breakpoint, it will just run it straight through. And that's great, that's fine. But in the gutter on the left hand side where we have the numbers, all that kind of thing, you have a section where you want to put in breakpoints. And so you put in a breakpoint just by hovering over it and clicking, and then you put in that breakpoint, and that will stop execution on that line while you're running. So if we click the play button now, we've got the breakpoint, and it will pause on line 12. And so what we want to do is have a think about what will happen when line 12 executes. And so what we would like you to do is to write on the line above each line what you think will happen, and then see if it does. And so in this one I've written, I think this will print hello, let's get started, by calling the print function. And so that will print down here in the terminal. So let's see if that's what happens. So we're running it, and we've got the commands here. So this is our line that's active, and then up at the top are our debugging commands. So we want to click the step over command, step over button even, and so that will execute the line that we're on and move to the next line. Okay, so let's keep an eye down here at the bottom in the terminal on what's going to happen. So we've stepped to line 14, and it's printed hello, let's get started, which is what we expected it to do, which is good, right? So if we go to the next step, where we think, okay, well, this is where on the left here, we've got this little yellow thing which is showing us where we're going, and we're seeing that we're defining some words as a list of what does this line do. Okay, so when we run that line, we'll see, we step over it using that step over button, we'll see that we go to 16, which is the next line, which means it didn't crash, which is good. But we have a new variable up here called some words. We've defined this variable some words, and it's a list, and we can get into that list and click the little arrow. You can have a look at what's going on, and that sort of explains everything that's going on there.
So let's do that again as a live coding example. So first thing we're going to do is put in a breakpoint, and we're going to put it just there in the gutter. And you can see where a breakpoint is possible because it will pop up a little red thing. I can't, oh I can. Sometimes you can't put a breakpoint in, it'll jump to somewhere else, but it doesn't seem to be stopping me at the moment for some reason. So let's step through this a little bit and see what happens. So we go to the run and debug, and then we click the start debugging button, and we get our controls, and we get our terminal, and it's just sitting here waiting for us. So what we're seeing here is that we've got really nothing happening because we haven't declared any variables, we haven't actually done anything yet. This is the first line that really does anything that you'd have to interact with. So what I want you to do in this exercise is to comment just above each line. So this one's been done. I think it will print, hello, let's get started. So if we step over that line, we see that it did actually print down here, hello, let's get started. And so what we would do here is we would make a comment, and I say, I think it will declare a variable called some words, and it'll put a list of strings into it. That's what I think is going to happen. So we want to have a look at what our locals are doing over here and just see. So we step over that line, and it did. So it's created this new variable called some words, and we can expand that and we can see what's in it. So what does this line do? Question mark. It's done it. That's great. Now, this is just a little tricky, is that your code doesn't expect to be modified while you're actually running it. So it's got a bit out of sync on what the lines are now. So you saw I had to jump over that twice. So it's a bit confused. So let's stop it, take out that breakpoint and put the breakpoint where we want it to stop next time, and just restart that. Maybe one day it'll fix that. So now we've got this new thing here. It's going to go for word in some words, print word. So this goes back to the example that we had in the slides, that we're going to iterate or loop over a list of words. And so what this is going to do is, for every word in this list, it will print that word. That's what I think will happen. So I would then type in above this what I think is going to happen. So let's test that. So step into the loop, and it did. It printed what? And then step into the loop. Does this line do? Question mark. So once that gets back to here, what do we think will happen? Well, okay, there's nothing left in that list, so the list has been exhausted. So we step, and it steps to the next one. So for X in some words, print X. So let's see what that does. What does this line do? Question mark. So what this is showing us is that this word and this word, they're just variable names that you get to define. They're not anything specific or magic. You can call them anything you like at all, as long as they match the Python variable naming rules. So if we step over that, we print some words, the whole of some words. What does it print? Oh, it prints the list, formatted as a list, so we can understand what's going on. And then what's this doing? So if len some words is greater than 3, so len gives you the length of a list, the number of items in that list, or number of items in a number of characters in a string, or anything that it's something that implements the length property. So let's step over that. Yes, so that resolves to true. Now what we can do here is just check that, so we can mess around with it a bit, because we're in the debug session. We can do it. So length of some words is greater than 3 is true. Is the length of some words greater than 10? False. Is the length of some words equal to, how many things are in that? 1, 2, 3, 4, 5, 6. 6. True. Is equal to 7. false. So we can mess around in that debug session quite nicely. All right, so let's step over, go back to the terminal, step over that line, and that prints that. Now, that just defined that function, and then here, this line here is calling that function. So if we step up here, it just prints a bunch of stuff about my computer. It says that my computer is called Bendy laptop, it's got Windows 10, blah, 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 blah. And then that's it, that's the end. So that's what we want you to do in this exercise, is to step through and play around with this file and just learn how to use your debugger.
Okay, so once you kind of work through that, you'll understand what we're kind of getting at. Debugging is a real skill. There's a lot more to it than that, but that's basically what it is. It's super useful. I do it all the time. Maybe like 80% of your time is spent debugging rather than actually writing code. Okay, exercise 2 is this very broken file. So there's lots wrong with this file. You've got to go in there and find the words that are wrong. So in this case, you've got the word det instead of def. And so that word is underlined. So that's the first error it finds, and the computer can't handle it multiple errors. So it's just like, okay, there's a problem here. And so once you've changed that to def and you've saved it, so you Control S to save, or Command S if you're on a Mac, and it'll highlight the next problem. And so whatever that is, it'll give you the next one. Once that all works out, it will tell you what's going on. Now, this red underline is a lot more useful than the stack trace you get at the bottom here, because it says get letter and it points at the R in get letter, not in the T in det. They've upgraded that in the last week or two, but it depends whether you're on Python, what Python you're on. I think you need to be on 3.10 for that to work, and I don't think anyone is on 3.10. I don't think even I'm on 3.10. So you just have to get used to seeing that actually these error messages aren't actually very helpful sometimes, and learn how to see what they're actually trying to tell you.
So a live version of this, the latest version of VS Code that this is recorded on, is actually pretty helpful. So it's got all sorts of like underlining error messagey bits. I don't know how much of this is because it's my setup and how much of it's because it's yours, so you'll see what you get. So let's go through and change some of these. So we know that det should be def. And then we save that, and suddenly a whole bunch of errors disappear. Right. Now the next error is here with this bracket. So what that's saying is it's expecting a round bracket. Now, it's only expecting a round bracket because it is looking at the left-hand bracket and saying, oh, I expect the same to be on the right. That bracket is actually right because we're using square brackets for indexing. So what this is this alphabet variable is a list, and so it wants to index into the list. Now we've changed that to a square bracket, and this whole section is just happy. Now, what's going on here? Set 2 exercise 2, not a very helpful name for a function, but it is saying, well, I don't know what's going on here because that's a semicolon. So if we hover over that, Pylance, which I think is what you will have, I don't think you have to set it up now, is saying it's expecting a colon, not a semicolon. So let's replace that with a colon. And then suddenly a bunch of things get better. But we've got a colon here. We don't need that. We need a comma, and so on. So save that and say, okay, well that makes sense. Now, word array is actually word array is going to be a list of characters, right? Because we're going to map this get letter function over these numbers. So what we're going to say is, we're still going to need square brackets to index into these things. So we can do that, and then that, and they're happy again now. Now, but this is a function, and so it needs to be called with round brackets. Okay, so that's happy. And then we come down here. Okay, there shouldn't be a space there because that's looking for an equality thing. Save that. How's that looking? It's going okay, pretty close. It doesn't understand print. It wants to know what print means. So we then print that and save it, and it's all fine now. There's no curly things. So once you're there, you can run that code and see what it prints out.
Then exercise 3 is much more like exercise 0. It's just a case of crushing your way through a whole bunch of these tests. There's a lot of them. They're hard, so you'll get there in the end, but you're going to have to think. So if you like doing Sudokus or you like doing crosswords or that kind of thing, this will give you something to really get your teeth into. And so remember to be filling in your lab book. So if you're filling in your lab book, they'll give you some ideas about what to do. You can write down and be like, oh, I did that, I did that, I did that. And you can see what you tried and didn't work. And so it's not just what did work, it's also what didn't work. And so once you're done, remember to commit and push to GitHub, because otherwise then I won't know you're done if you haven't committed and pushed.